Now that we understand how to convert between rectangular and cylindrical or spherical to cylindrical, we know all of these formulas, which we've derived. They should make a reasonable amount of sense, but we want to be familiar with them. And when we deal with our dv, integrating with respect to three variables, with x, y, and z, we just say dx, dy, dz. When we have cylindrical coordinates or even polar, we've got that extra r factor. Well, when we're dealing with spherical coordinates, we also have this extra factor, which is rho squared sine phi. So anytime you have a triple integral in these spherical coordinates, you're going to have that extra factor, rho squared sine phi. I'm not going to derive that. I'm going to put you to the text if you want it. I'm just going to ask you to trust me, to know that it's there, and to remember to put it in. So let's do an integral. Just make sure we can integrate properly with spherical coordinates. So for this example, we're not going to deal with converting, but again, if this was in rectangular Cartesian coordinate system and we converted it, we would have to use or add in this extra factor. Here it's already given to us in cylindrical coordinates, so we're just going to evaluate, but you'll notice that extra factor is there. So looking at this first integral, we're integrating with respect to rho. So now I have 0 to pi, 0 to pi, and rho, that's going to become 1/3 rho cubed, and of course sine of phi is just a constant, so we need to evaluate this from rho equals 2 sine phi to rho equals 0, and then we'll have d phi, d theta. So I'll go ahead and pull that 1/3 in front. I got 0 to pi, 0 to pi, and I'm going to end up with 2 sine phi cubed. I should put my parenthesis properly. 2 sine phi cubed sine phi, and of course when I plug in 0 to that row, it's going to zero it out, so I don't need to write minus 0 cubed sine phi. So we've got d phi, d theta. So 2 cubed is 8. I'm going to pull that 8 out in front. I've got 8/3, 0 to pi, 0 to pi, and now I have sine to the 4th phi, d phi, d theta. Now integrating sine to the 4th, we have sine to the 4th phi here. We can use half angle or double angle reduction formulas to help us with that, but it gets kind of messy since this 4th isn't an odd power, it's an even power. So I'm going to use an integral reduction formula from our table of integrals. So this could get quite messy again for us to integrate. So I'm going to work this with n equal to 4, and my a value is the coefficient on phi 1. So this is going to be, when I integrate this with respect to phi, I'll have 8/3, 0 to pi, and I will end up with, let's see, we've got negative sine to the n is 4, n is 4, the a value, anytime we see that, we're going to use 1. So sine 4 minus 1, sine cubed phi cosine phi over 4. We need to evaluate that between our bounds, phi equals pi and phi equals 0. And then we've got plus n minus 1, that's going to be 3 over 4. We've got the integral from 0 to pi of sine 4 minus 2 is, we'll have a 2 there. So sine squared phi d phi. And then, of course, we'll still need to integrate with respect to theta. Now, the nice thing about this first term here is when I plug in pi or 0 for phi, sine of pi and sine of 0, those are both 0. So this whole value is going to go to 0. So I've got 8/3, the integral from 0 to pi of 3/4, the integral from 0 to pi of sine squared phi d phi d theta. So now that we need to integrate sine squared phi, this is where we use a reduction formula again. I'm going to have 8/3. Actually, I'll go ahead and pull that 3/4 out, which gives me 2, 0 to pi, and then I've got 0 to pi. For sine squared phi, I'm going to use 1/2 times 1 minus cosine of 2 phi. And then we've got d phi, d theta. So that 1/2 and the 2 are going to go away. We've got 0 to pi, 0 to pi, 1 minus cosine 2 phi, d theta, and this becomes very easy for us to integrate. So just looking at the inner piece with phi here, we've got 0 to pi, I'm going to end up with phi minus the sine of 2 phi over 2, evaluated from pi to 0, and then we'll still integrate with respect to theta. Plugging in pi or 0 here, both of those terms are going to go to 0. So all we're really going to end up with is just this original pi, because we'll have pi minus 0 minus the quantity 0 minus 0. So this is pi, 0 to pi of d theta, which is pi theta evaluated from pi to 0, which gives me pi squared. So pi squared is the value of this integral simplified using cylindrical coordinates, right? So an integral in cylindrical coordinates. As always, email me if you have any questions or concerns or comments, and good luck.